In this paper, we will be discussing a battery thermal management system with an integrated hybrid cooling system.
Why do we want this paper? Well, it is to propose a lumped battery thermal management system model with hybrid cooling that will allow for faster charging rates and maintain an optimal battery efficiency.
By combining the thermal models for the battery pack, natural convection, and PCM-based thermal resistant networks, we can develop a simplified model that does not require 3D simulation to predict temperature levels across the system.
To conclude, the lumped model was 1% less accurate and took 3.9% of the time needed for the 3D numerical model for calculations. The lumped model is able to predict the cell-to-cell temperature variations along with the average temperature of the model. On this slide, A is an overview of the entire model, B is a view of the cross-sectional area.
Okay, I was in charge of the ANSYS simulation for this paper. So what I have so far is I created a 3D model of a single battery cell with free flow channels on the right and left sides for the liquid cooling system. I also added positive and negative tabs to the top. In this model, I have made the assumptions that the mass flow rate in all the elements of cooling plates is uniform and that the battery will have a constant mass. On the left, I have generated a mesh with an element size of 2 millimeters, which results in about 57,000 elements. And I initiated a simulation on the right of the flow through the channels. What I will add in the future is chambers for the phase change material and the aluminum casing of the cooling plates, which encompass both the active and passive methods of cooling. And I will also run a simulation and compare the values to those in the paper for a single battery cell.
When it comes to modeling this system in MATLAB, we must base the code off of the main thermal governing equations for each system. You can see these equations on the top right with the battery, the cooling plate, and the phase change material. On the bottom right, we can see a graph that depicts the relationship between the temperature of each battery cell and the respective cells at the bottom. And for right now, this graph is not taking into account it's not taking into account the coolant, and it also does not have an electrical model for the generation of heat for the battery, but that will be added at a later portion of this project.
For the financial aspect of this project, this is a very broad breakdown of what I'm hoping to do in the future. I reviewed several business proposals and will be treating the rest of this project as such. After reviewing the different business plans, I came up with 6 main breakdown points that are still very broad. First being experimental materials. These are all the materials associated with the theoretical and the physical experiments. 2 are model materials, so these are models that are per unit costs. 3 are facilitation costs, which is the amount needed to rent a space, to carry out the experiment, to build the models, etc. 4, machinery costs, deciding if we're going to have machined plates and/or welds in the future. 6, personal costs, wages and hourly rates for employees, and 6, analysis of cost reduction. So on the next slide, we have the overview of the experimental costs. In a lot of the different business plans that I reviewed, this is where they started. They started with the experimental costs. In our specific project, I broke it down into 5 different experimental material costs. First being the single cell setup. Within number 1, there are many different components that I'm still looking into. Number 2 is the CTS climate chamber. Number 3 is the battery module. And number 4, PEC battery module tester. And the 5 is the chiller and pump. I reached out to 2 different companies, and I'm waiting to hear back from one other one about renting and/or buying these products moving forward with our project. Right now, I'm planning on focusing on the overview of the experiment before moving any further within the breakdown that I set up on the previous slide. And overall, I'm interested in seeing how this plays out. Thank you.